Okay, today we're working on lesson 4, vector laws. So we are looking at vector laws today, and your goal today is I can apply the rules for vector addition to applications that model real-world situations, preparing me to apply them in a physics context. Part of this first unit does involve a little bit of physics, so people that did not take physics, you don't have to panic. It's a deep breath. Just looking at the vector addition and subtraction, so you're not worried about interpreting the results. So keep that in mind. So we're only worried about adding and subtracting vectors. I'm going to show you the different ways to do it. So again, this note pre-filled in, so you may want to pause it to copy it down and then listen to the ramble after. So if u and v are vectors, so we're talking about two vectors, u and v, we have a couple of properties or rules that we follow. So the first one's what we call closure. So just give you an idea where I am. So we're on closure here. What closure means is that if I add or subtract vectors u and v, I end up with a vector. So a vector plus a vector will result in a vector. Okay, so that's our closure property. The next one is commutative. What does commutative mean? It means that if I take vector u and add it to v, or take vector v and add it to u, it will be the exact same result. It's like saying 1 plus 2 is 3, 2 plus 1 is 3. So it doesn't matter what order you add in, they still give you the same answer. Associative. So we talked about this in the first lesson, some of these. Associative, it means that if I'm adding 3 vectors, which I'll be able to do in the end here, if I add u and v and then w, it would be the same as adding u to v plus w. So the order does not matter. Distributive property. Or distributive property. So if a and b are scalars, it's just saying that a multiplied by u plus v is the same as au plus av. All right. And finally, the identity. The magnitude of the zero vector, we have to accept the magnitude as being 0. So there we are. So those are the base properties that we're going to use or are tied in with today's lesson. There's nothing I'm going to ask you to regurgitate, so please don't memorize. Please don't put it on your cheat sheet. It's a waste of space. Okay? It's just stating the obvious in most cases. You've done this with numbers and algebra, so I'm just putting formal names to them. Okay, there are two laws for vector addition. So I'll go through this and show you the geometric methods. So when adding or subtracting two vectors, we can use the triangle law. So the triangle law, it looks like this. Step 1, we draw the two vectors. So I'm right here. We draw the two vectors head to tail, and that's extremely important that we do it head to tail. So over here are my two original vectors. So these are the two I'm going to add together, u and v. I now arrange them so that u and v are head to tail. So here's my tail for u, here's my head for u, tail for v, head for v. Okay? We then draw in a line that extends from where we started to where we end, and we call it r, and the reason it's r is our resultant. The resultant, fancy word for answer. So that's what we call the resultant vector. So step 1 again, we draw the vectors head to tail. Then we can move on to step 2. In step 2, the sum or the resultant, the r vector, is measured from the tail of the first vector, so where you started, to the head of the second vector, where you finished. So to solve for r, so I'm down here in the written part. How do you solve for r? Have to use cosine law first, because what are you going to know? And I'll show you over here with that diagram, and I'll use blue. When you do the vector addition, you are going to know this angle, and I'll show or explain the y when we do an example. You're going to know that value. You're going to know how big u is, and you're going to know how big v is. So that is why step number 1 is to use the cosine law. What's the cosine law going to give you? The cosine law is going to give you the magnitude of your resultant. So you are going to know how big r is in your first step. The second step, you have to use sine law. Okay, and sine law is going to give you your direction. And all of this, I will do an example to show you how this works. Okay, so there are your basic steps. Now there's a second law called the parallelogram law. It's really the exact same as the triangle law, so I don't try to teach it in that fashion. It just sometimes it helps people rearrange their vectors. So what's the difference this time? So here's the major difference in the first step. You take your two vectors and you draw them tail to tail. Okay, so again, here are the original vectors. And what we're going to do is we're going to draw them tail to tail. So here's my diagram. So tail to tail, so you'll notice now that u and v both start right here. Okay, so we draw them tail to tail. The second step, we're going to create a parallelogram using the two vectors as the sides of the parallelogram. So if you look at what I've got sketched here, vector v, on the opposite side, I draw a vector v, vector u, and what happens when you draw the parallelogram, you end up with a closing point, which becomes the location of the head for your resultant vector. So your third and final step then, you draw the resultant vector, which extends from the two tails to the two heads. And now you've created a parallelogram. Now you do the same steps as you did previously. So what's the difference here? You're going to know the magnitude of this vector here. So you'll know that value. You know how long, or you know the magnitude of u. And from geometry, you're going to know this angle. And again, I will show the process there so you can see in action. All right, so there we go. So there are the two laws. Now I'm going to do an example to help you follow through. All right, so in this example, if vector u is 10 units in length, vector v, so you notice they just give me magnitudes. And the angle between the two vectors, when placed tail to tail, is 30 degrees. So what this does is this kind of pushes me down a certain path as to what method I'm going to use. Because if you draw out the situation, so you draw the scenario here, I've got vector u heading in that direction, I have vector v heading in that direction, and they're arbitrary, the directions, u and v. They told me that if I place them tail to tail, the angle between them is 30 degrees. All right. So I know that the magnitude here is 10. I know the magnitude here is 5, which means I've over-exaggerated that vector, but that's okay. So, oops, moving this down then a little bit to give me some space. I'm going to continue just using the parallelogram method. All right, just because I've already got them drawn tail to tail, so I might as well continue with that. So I can cheat with the smartboard. I'm going to have that same vector, and like I said, we're creating a parallelogram. So I've moved the u vector over here, and I'm going to end up with the v vector right there. So there's my v vector. So now my resultant vector will extend from the two tails all the way to the two heads. So there's my resultant vector. I know that this side of the triangle is 5. I know that the magnitude of u is 10, so I know that side of the triangle. I need to find this angle. Well, I already know that, and follow me along with the grade 9 geometry, so I'm going to use a green marker here. We know that this angle is 30 degrees. If I was to extend the v vector out here, I know that this angle would be 30 degrees. And that's because of the F pattern. You remember back to grade 9, the good old days when you thought I was the meanest teacher in the world? Hasn't really changed, but still, here's your F pattern. So the armpits of the F are the exact same measure and angle. So that means that, using complementary here, 180 in a line, if you take away 30, that angle will be 150. Okay? So to find the magnitude of R, okay, so step 1, magnitude of R, we are going to use cosine law. So So of course I'm adding all the steps in here for note purposes. Cosine law. So labeling my corners, and like I said, it doesn't matter at this level of the game. A squared plus b squared plus c squared minus 2bc cos of angle A. So the magnitude of r squared, I'll keep it in this format for now, so this is my side A, the unknown side, is equal to, and I'm going to put all the steps in here then, the magnitude of u squared plus magnitude of v squared minus 2 times magnitude of u, magnitude of v, cos A. I'm quite happy with you skipping that step, but it's something I want you to remember. It's something that can go on the cheat sheet. This is what it looks like, the cosine law when you're dealing with vectors. I'm just going to isolate magnitude of r, which means I'm going to take the square root of this entire side. Magnitude of u, it's just 10 squared. Magnitude of v is 5, so 5 squared minus 2 times 10 times 5 cos 150 degrees. So there we go. You can do a little bit of cleanup. So the square root of the first is going to be 125 minus, and remember you cannot group these together because cos, you cannot do 125 minus, 100, okay, because of the cos 150. And that's as far as you can simplify it. We don't have calculators, and I don't want you to worry about doing it in your head. So there you go. So there's the magnitude of r solved for. Now we need a direction. So I need a direction. So I'm looking for an angle. So back to my diagram here. I need to find this angle. I'm going to have to reference it from V. Well, it's inside the triangle that I just was working with. So let's call that angle theta. So I want to find angle theta. How am I going to find angle theta? Well, using the sine law, I know that sine theta divided by magnitude of u. Okay, so it's an opposite side situation here. Okay, theta, here's my opposite side right there for theta. Okay, equals, I know the magnitude of r, I just calculated that, so I can use the sine of 150. So sine 150 over the magnitude of r. So what am I solving for? I'm solving for theta. So sine theta would equal magnitude of u sine 150 over magnitude of r. So theta would equal sine inverse. Magnitude of u was 10. Sine 150, I don't have a calculator, so I leave it as is. And r has been defined up here. Okay, you've defined it for me. You put a box around it. You said this is the magnitude of r. Don't have to carry it around. You just say that's the magnitude of r. And there's your angle. Okay? So you'd say, therefore, the resultant would be magnitude of r, that's above, at an angle of theta, and then you'd tell me that's already calculated above, measured from vector v. Okay? If you look at it, that angle, that theta, is measured from vector v. Okay? So there we go. The whole process without using a calculator. All right? So you can carry ahead variables like magnitude of r, and I don't need you to replace it with the expression because, again, my focus is on the process and the skills, not on whether you can use a calculator. All right.